Okay, today we're going over 9.1, inverse variation. So the definition, the non-mathematical definition, is the opposite in order, nature, or effect. And the mathematical definition is a relationship between two variables expressed by an equation in which their product is equal to a constant. All right, so if we take a look at these two equations here, then we know what this one should look like, the y equals kx. So we're saying k is a constant, meaning it's not changing. So if we put a number on that, we could say y is equal to 2x. And therefore this would be linear. It would be a direct variation. Direct variation is just a linear equation where your y-intercept is 0. So your slope would be 2, it would go through the origin, and you'd rise 2 and run 1. If we look at this one here, y is equal to 2 over x, if we plug in k to be 2. This one is going to be a type of inverse variation, and it is going to have asymptotes, and that is because we're not going to be able to have 0 in our denominators. So therefore x cannot be 0 and y cannot be 0. And this is what it would look like. So here's our inverse variation. It's going to be in the form of y equals k over x, where k is our constant of variation. If you're solving for your constant of variation k, it will be x times y is equal to k. And that's just because we just moved some variables around here. We take our equation. If we solve for k here, I can multiply both sides by x. My x's would cancel here, and then therefore k would be equal to xy. And we know that k cannot be 0, because if k is 0, then that would just make the equation y equals 0, which that would not be a inverse variation, it would be a horizontal line. Alright, so if we take a look here, the table and graph shows the time needed to bike 24 miles pedaling at different rates. So we know it's 24 miles because we should remember the equation of distance equals rate multiplied by time. Sorry about my messy handwriting, still getting used to this tablet here. So if we're looking at these, your rate and your time, if we multiply them, 3 times 8, that's 24, 6 times 4 is 24, 12 times 2 is 24, and 24 times 1 is 24. So if we actually go ahead and graph all of that, this is what it's going to look like, which is actually going to give us that your d is equal to 24, or we can actually rewrite that so that it's going to be a inverse variation, where it's going to be, we can rearrange this, and it could be your time is equal to 24 over r. Okay, so if we need to write a function that models the inverse variation, then we're going to be plugging into our inverse variation equation. We know this is an inverse variation equation because it says that x and y vary inversely. So that's telling us to use this equation here. So then we're going to just substitute the given values of x and y in. So it's telling us that y is -5. It's telling us that x is 3. We can solve for k now, so multiply both sides by 3, and therefore k is equal to -5 times 3, which is -15. And then we'll just plug in that -15 back in for k, and therefore get y is equal to -15 over x. Alright, for this one we need to determine if the relationship between the variables in each table is a direct variation, an inverse variation, or neither. And then we're going to write a function to model the direct and inverse variation. So if we take a look here. Direct variation, which we went over in the previous slide, is y equals kx. It's a linear equation where your y-intercept is 0. Inverse variation will look like this, y equals k over x. So if we actually solve for k in each one of these, for this one, your k would actually be, if I divide both sides by x, it would be y over x here. And if I solve for k here, my k would be y times x, or x times y by the commutative property. So let's take a look here. If we multiply these, we're not going to be getting the same number. So if we divide them, make sure you're dividing y over x. If I divide 18 over 6, that will give me 3. 6 over 2 will give me 3. And 1.5 over 0.5 will also give me 3. So therefore, since we divided y over x, and every time we got a 3, that's going to satisfy our direct variation, where your k will be equal to 3, and therefore we will plug it into y equals kx, or y equals 3x. So this is the equation that models this, and we also know that it is a direct variation. Alright, for this one here, we'll do a similar thing where we're going to look to see, should we divide y over x? Will that give us the same thing, or the same constant of variation, or should we multiply x times y? Will that give us the same thing? So if we take a look here, we're going to be looking at, if we multiply all of them, let's see what happens. 12 times 0.2, that's going to give us a 2.4, because we just do 12 times 2 is 24 and move the decimal over one time. If we do 4 times 0.6, that will also give us a 2.4, and 2 times 1.2 will also give us 2.4. So therefore we got k when we multiplied x and y, therefore it will satisfy our inverse variation, and therefore we'll get y is equal to 2.4 over x. And that is our function that models this this inverse variation. Okay, so if we take a look at combined variation now, we're looking at the combined variation, the wording of it, and then how it will be written as an equation. So if we look here, it says y varies directly. We know that directly means to multiply, and we can think of the directly equation as y equals kx. So directly we think of multiplying with the square of x. The square of x just means x squared. So we get y equals kx squared. Y varies inversely. Inversely means to divide. So inversely with the cube of x. So I'm going to write that one as y equals, we have our constant of variation k. Inversely means to divide, so we're going to divide that by the cube of x. So therefore we get x cubed. This one, jointly, means you're multiplying by more than 1. So z varies jointly with x and y, just simply means z equals kxy. Z varies jointly, so jointly we know that it means to multiply by more than 1. Jointly with x and y, so we can first write that out. So z varies jointly with x and y, so k, make sure you always put your constant of variation, xy, and inversely with w, so divided by w. Okay, and then this one here, z varies directly with x and inversely with the product of w and y. So we have directly with x, directly means to multiply, so directly with x, we have our constant of variation, x, and inversely means to divide with the product means to multiply also, of w and y. So divided by wy. Okay, and then finally we have to describe the combined variation that is modeled. So to do that, we are going to write this as, if we have pi is a constant because it's not changing, so it's a number. So we have your pi is your constant of variation, so we're just going to write that as, we don't write pi in. So for the other ones you saw that they didn't say k in there, your constant. So we're going to say A varies directly, because you're multiplying, directly with the, since it's r squared, we're going to write it as the square of r. You could have wrote r squared. You could have written r squared as well. Okay, for this one here, again, your 2 is a constant, so we don't write that in. So we're going to say that we have v equals 2a over b. So you can say v varies, since we have 2 times a, times would be your directly, so v varies directly with a, and then when we're dividing we say and inversely, because inversely means to divide, inversely with b. And that's describing the combined variation that is modeled. And that is all for your 9.1 inverse variation.